Now we are going to discuss about the parallel plate capacitor. A capacitor is a system of two conductors separated by an insulator. So capacitor means it is simply two conductor arranged in a small distance. Capacitor is a system of two conductors separated by an insulator. So we are considering one conductor. It's a conductor and we are giving charge for this conductor. We are giving positive charge for this conductor. Now it is having positive charge and we are placing another conductor here. It is also a conductor. Because of this positive charge, there will be development of a negative charge. The process is known as induction. Because of this induction, there will be development of negative charge and this side will be positive. There is a formation of opposite charge. Here it is positive and here it is negative. Because of this positive charge, there will be induction. Because of this negative charge and positive charge, there will be change in the electric potential. This negative charge will increase the electric potential. This positive charge will decrease the electric potential because they are same charge. There will be electric field in this direction, and here this negative charge will decrease the electric potential. So we require only negative charge here. So what we can do is we can earth this side. This distance is d. We are going to earth this side. When we are earthing, the all positive charge will flow towards earth. So it is now it is a negative charge only, and we can increase the charging capacity of this conductor. We can give more charges here. So this is the working principle of a capacitor. If we can increase the charging capacity by earthing. This arrangement is known as parallel plate capacitor and is the working principle of capacitor. Now we are considering capacitor. Area of conductor is A and distance between the conductor is D. This is positive charge and this is negative charge, and this side is earth. We are not showing that here. This side is earth, and the direction of electric field E is from positive to negative. What will be the expression for electric field E? We know that electric field because of charged infinite sheet is equal to sigma by 2 epsilon 0. And we are considering the capacitor. This area is region 1, region 2 and region 3. Now we are considering this conductor only. We are not considering this one. From this conductor there will be electric field in this direction, right? It is sigma by epsilon 0, and there will be electric field. The same electric field will be here in this direction. It is also sigma by epsilon 0, and the electric field will be towards left. Also there will be electric field. It is also sigma by epsilon 0. Now we are considering the second plate. In this region 1, region 2, region 3, there will be electric field, but direction will be opposite. So here direction of electric field will be from left to right. This is the direction of electric field. It is sigma by 2 epsilon 0. Region 1 also there will be electric field, sigma by 2 epsilon 0. In region 3 also there will be electric field. It will be in opposite direction of this sigma by 2 epsilon 0 because field will be always towards negative charge, so it is also sigma by 2 epsilon 0. So there are three regions, and we mentioned the value of electric field in each region because of this positive conductor and negative conductor. But this electric field is opposes this electric field, this electric field opposes this electric field, so it will cancel each other. These are cancelling each other, and there will be two electric field in same direction. The electric field inside the capacitor is in same direction. Both electric fields are in same direction, so they will add up. So E is equal to sigma by 2 epsilon 0 plus sigma by 2 epsilon 0, so it will be sigma by epsilon 0. This is the expression for electric field inside a capacitor. So it is a parallel plate capacitor which is having two conductors. The area of conductor is A, and distance between the conductors is D, and there is an electric field from conductor having positive charge to conductor having negative charge. The equation for capacitance C is Q upon V. So we can write C equal to Q upon V, Q by V, and E proportional to Q. When the strength of electric field will increase with strength of charge. If we are giving more charge, there will be more electric field. So we can write E proportional to Q. Electric field will increase with charge, and if we are giving more charge, we need to do more work to bring a charge from this point to this point. The potential is also depends on Q. If we are giving more charge, there will be more potential. Q proportional to V. So E proportional to Q and Q proportional to V. So we can write V proportional to E. To remove this proportionality sign, we can add a constant. Here the distance between these two capacitor, distance between these two conductor D is a constant, so we can add V equal to E into D. This D is a constant here, so we can add that constant for removing this proportionality sign. This proportionality sign, now it is equal, so equation is V equal to E into D. From the previous section we understood that the electric field inside the capacitor is E is equal to sigma by epsilon 0, and we are going to substitute the value of E here, so it will be V equal to sigma by epsilon 0 into D. What is sigma? Sigma is surface charge density, so instead of sigma we can add Q by A, so it will be V is equal to Q by A into D by epsilon 0. Instead of sigma we are using the relation Q upon A, so V is equal to Q upon A into D by epsilon 0. V is equal to QD upon A epsilon 0. Now the equation for capacitance C is Q upon V. C equal to Q upon V, and instead of V we can use this equation. Instead of V we can use this equation, so it will be C equal to Q upon QD A epsilon 0. This for dividing we are taking this multiplicative inverse, so Q into A epsilon 0 by QD. We are taking the multiplicative inverse of QD upon A epsilon 0, then C will be equal to Q into A epsilon 0 upon QD, and these two Q will cancel each other, then equation will be C equal to A epsilon 0 upon D. Capacitance of a capacitor depends on area of the conductor, distance between the conductor, and nature of the medium. Epsilon 0 indicate it depends on the nature of the medium.